Huh?
Sir, your voice is not audible, sir.
Hello.
Okay, we will go ahead with this three stages. Okay, and
Hello.
these three stages can be shown here. You can observe. Hmm? That's comparing big data and edge analytics. So it illustrates stage of data processing in an edge APU, because APU is mainly meant for processing. So it combines filters, what we have discussed already, that can be shown here in the diagram. So this is called as analytics processing unit APU. So here raw data is produced, multiple raw data, and now this edge analytics processing is going to perform the various filtering, combining, analyzing, all can be done here, and finally it produces results in terms of output data, and that we are going to again analyze more in deep by using Hadoop, like a MapReduce, Apache Kafka, etc., etc. So we use here some Hadoop ecosystems. So it finally analyzes in deep whatever you require it. This is a general structure of APU, that is Analytics Processing Unit. So now we'll see. In order to perform analysis in real time, the APU needs what I have discussed here. APU needs further some functions. It performs some functions. APU itself performs some functions. The first one is filter. As I told you here already, it filters, combines, analyze, etc. Now we will see here one by one. So the first functionality of APU is its filtering. The streaming data which we generate by IoT endpoints is likely to be very large, definitely, because a particular edge has any number of sensors. They produce huge data, and most of it's irrelevant. I mean, we don't really require those data. The data which we are getting from a particular sensors may not be required. Some are irrelevant, some are relevant. So then which are relevant, which are irrelevant for you, you have to filter them. For example, here we have taken a sensor may simply poll on a regular basis to confirm that it is still reachable. That means there is a sensor we have kept for a particular component of any system. That particular sensor is keep on always telling that still reachable, confirming about reachable. Some other data which we don't require, that should be removed. The filtering function, what it does, it identifies the information that is considered the important. That means filter component, if you apply into the APU, it identifies the information which is very important. That's it. Which is not required, it will not take up. The second function of this APU is transform. After we filter it, okay, so in the data warehousing, extract, transform, load, we use the word ETL operations. They are used to manipulate the data structure into the form that can be used for other purposes. So we do it next. We will transform into the next stages for further processing it. So analogous to this data warehouse ETL operations in streaming analytics, once the data is filtered, it needs to be formatted for processing. We have to format the data definitely after filtering. So it should be formatted for next step, what is processing. And third function is time. As I told, based on the timely responsive should be also there. If it is not there, latency can be increased, as I told you. Since we are using a real-time streaming data, a timing context needs to be established, and this could be correlated average temperature readings from sensors on a minute-by-minute basis. For example, you are taking some sensor data of a particular patient in a hospital on regular basis, like after every 10 minutes you are looking for his or her BP, blood pressure value. So after every 10 minutes, based on that, you can further go for diagnosis, whether what can be done. Should I further take give a further treatment or not, or is it going to be normal or not? Then you will be taking the sensor data on regular basis. Okay, the timely, after 10 minutes only you have to take. Likewise, there's one example. Yes, that's a temperature only. So we'll see that defining streams and windows, whatever we use. Okay, so this example establishing a time window for analytics of average temperature from sensors. So this one simple example, you can see, create a stream temperature. Here we have created, and we are selecting from the the table average temperature from temperature visible 2 minute advance. So we use like this. So based on that, so how the particular temperature values can be look like based on the timings that can be shown in the diagram. The fourth function of APU is correlate. So that means streaming data analytics becomes most useful when multiple data streams are combined from different types of sensors, because you use more number of different types of sensors. When you're combining the data of all those, then you need to correlate into the single point. For example, in hospital, several vital signs are measured for patients, including for example, as I told you, the temperature of a particular patient, BP, heart rate, respiratory rate. So for each function we use different sensors. Okay, blood pressure sensor is different from heart rate, and why, I mean, other functionalities also. So when you have a different functions to be checked a particular patient, then the we need to combine all the data, because I being a doctor, I need what, BP also value, I need a heart rate value, I need a respiratory rate, I need a temperature also. All together only I can analyze. That means we need to combine, correlate it. Okay. Yes, this is what for patients medical past medical history. For that we use all those things. Okay, so now how we correlate the data streams with the historical data. So here look at here, raw data, sensor data, combining, we are combining here. We filter, then transform and correlate, and here we use past data also, historical data together. We will produce the output. This is edge analytics core functions, which we can use for APU. And the fifth function of edge analytics is match patterns. Okay, once we have filtered, transformed, once we correlated, next is to we have to match some patterns. That means we have data, the data streams are properly cleaned, transformed and correlated with other live streams. Later we should be use some pattern like is it matching. I have already predefined. For example, you want to match current present situation. When you take a sample of a particular patient, then you should match whether it is positive sign or negative sign of a particular patient or a particular virus. Then we use some pattern. Function is improve business intelligence. Okay, the value of ultimately this why we need to analyze at the edges, ultimately for improving the business. Okay, like for example, conducting edge analytics on patients in hospital allows staff to respond more quickly. So this is what the staff can respond quickly, because when you have the data are available with you, and it reduces the volume of unstructured. Okay, so we can see here distributed analytics throughput, the IoT system, and which I have discussed, streaming analytics. Okay, let's see here, edge location processing platforms, and regional data centers. And here look at here, the different sensors are attached, and brokers will collect the value of various sensors. Various brokers finally are combined together into a single broker, and this data are used by streaming analytics, and you have any number of it, or directly can supply to another broker where it can be used as a value to be displayed for dashboard, for data visualization and a data lake. Okay, this is called as distributed analytics system. Where they act as a broker, which will be collecting the data, because we have already used word fog computing or edge computing. Okay,